All right, hello everyone. So I want to take some time to go over our special triangles and look at a few additional examples because I think at first it might be a little confusing, but once you get the hang of it, it's really just following the rules which we have here that we wrote down in class. And remember, the way we got this is using just our Pythagorean theorem, right? Because in the 40, 45, 91, which we see here, we know it's isosceles, right? The legs are congruent to the ones opposite the base angles. So if I did my a squared plus b squared equals c squared, so that would just be the x squared plus x squared equals, if we want to find the c. We did it with one, but I could do it with x as well because, well, x squared plus x squared is, I just had the numbers in front, right? So 1x squared and 1x squared is 2x squared. Okay, so if I want to find out what c is, I could take the square root of each side, right? So I know square and square root undo each other. So c on this side would be equal to, well, if I split this up, the 2 and the x squared, well, the x squared gets to come out of jail, right? Because square and square root undo each other, and the 2 stays under. So this is just going to become x on the outside and then radical 2, right? So whatever x is, it's just going to be times radical 2. You could do it with 5, you get 5 radical 2. You could do it with 10, 10 radical 2. As long as isosceles, this will always be radical 2 times more. And we said going in the reverse direction is divide by radical 2. Right? It was the same thing. I'm not going to go through it for the 30, 60, 90, but when we did our Pythagorean theorem, those are the relationships we got, right? So always, we said short was our key one. So always go to the short leg first, or for given that it's the easiest example. So short leg's hypotenuse is always double or half going backwards. And going from short to long is times radical 3. So similar to the radical 2 on the left, but just 3 instead. So we said this was easy as 1, 2, radical 3. So the easy way to memorize it, just 1, 2, 3 with the radical over the 3. Alrighty, so let's I want to take a look at the second page of the packet. So I know we all have this packet. So this punchline here. So we get the answers. It should spell the punchline to the joke at the bottom there. So I want to go through just a few of these. I'm going to give you the chance to finish off. I think the last one's a little bit confusing, so I want to go through how to set up that one. But once you see what you have to do, you could finish it off. So if we look at this first one here, I think maybe starting with the 40, 45, 90 over here would be the easiest because we did that first. And I always like filling in the missing angles here, right? So if that's 45, this is also going to be 45 degrees, right? Which means it's isosceles. So what would M be? Okay, so this is 53 here. We know the legs are congruent, so M would also have to be 53, right? Okay, and then the hypotenuse. So to go from the legs to the hypotenuse in a 40, 45, 90, my rule is multiply by radical 2, right? So if this is 53, this is going to be 53 radical 2. Okay, so I receive 53, I'm going to put an M, and 53 radical 2, I put an I. So 53, we put an M, and we're in 53 radical 2 is here, so we put an I. Okay, so we're already on our way to spelling that out. Okay, let's look at, we can look at this one. So I have this triangle here. Okay, so first thing I should ask myself is, what is this angle? Well, if it's 90 and 60, that would be 30, right? 30, 60, 90. Okay, so always identify the short leg first, right? So the short leg is across from the 30, so this is the short leg. Okay, and I'm given the hypotenuse here, right? This is the hypotenuse. Okay, so remember the relationship between the short leg and the hypotenuse is double, right? So to go from the short leg to the hypotenuse, it's just times 2 or divide by 2 going backwards. So if this is 84 to go to the short leg, this would be half of 84. So that would be what, 42? And it doesn't ask for it, but then if I want this side, that's the long leg, right? That's the side across from the 60. So this is the side across from the 60. So that would be to go from the short to the long, that's multiplied by radical 3, right? So 42 rad 3. If it asks me for that, it does not here. Okay, so where we see 42, we put a G. So 42, we're putting consistent with right here. So that would be G. Okay. And then we have this one here. So if I want to look at this final triangle here, we need to get A at the bottom here. So we have this triangle here. Okay, so notice none of the angles are labeled, but it does tell me one important thing down here, right? It tells me that MT is parallel to HG. So if I look at MT, that's here. And if I look at HG, that's down here. Okay, so notice if I have these parallel lines, we have a transversal here, right? I'm running out of color. So here's my transversal. Okay, so just to help to visualize this, here's my parallel lines here in black, and there's my transversal. So notice we have alternate interior angles here, right? That should really help you visualize it. So if that's 30 degrees, this is also going to have to be 30 degrees. Okay, so if I get rid of the black here, you could see those alternate interior angles. So if you're not able to identify looking at that, extending those lines out might help. Okay, so that also means if that's 30, well, then this would have to be 60, right? Because we need a 30, 60, 90, so we need 180. So we do have a special right triangle here. So always identify the short leg. So where's my 30 is here. So that means the short leg is 53. Okay, so we could find the other side. So if we want to go to short leg, if I want to go from the short leg, so we need the long leg here, right? So that's the A. Okay, so remember, short leg to long leg, it was we go multiply by radical 3, right? So if I want to go from the short leg 53 to the long leg, this would be 53 radical 3. Okay, I know I could also do this one if I want. So I double it, we get what, 106. So that would be how I figured that one out. So let me go down here. So if we see an 53 radical 3, we put an A. So this will be here. Okay, so that one as well. So I think you're able to finish this off if you just to make sure we're on the same page. So here we have equilateral. So remember, equilateral means all the sides are the same, right? So all sides are the same. This side is split in half, so I won't put the tick mark there, but this would also be all three sides are the same. Okay, which means all the angles are 60, right? So that's 60, that's 60. And this would also be 60. But notice, what do I have here? What do these markings tell me? It tells me it's an angle bisector, right? It's cut in half. So the 60 is being cut in half. So this would be 30 and 30, right? So notice we do have a special 30, 60, 90 triangle here. Okay, so remember, we always start with the short leg. So the 30 is here. So that means the short leg would be down here. Okay, so notice we're given the hypotenuse, right? So we're given the side across from the right angle. So remember, short leg hypotenuse is always double, right? So this is 8, this would be 4. Okay, and then short leg to long leg is the radical 3, right? So this would be 4 radical 3. Okay, so wherever we see a 4 radical 3, we're going to put a P. So I think there's a P here and a P here. Okay, so I'm going to have you finish. I'm going to explain one thing on the last one, but I'll have you finish this as well. This one, it tells us it's a rectangle. So we could ask ourselves, what do I know about a rectangle, right? So that means we have right angles here. So that'll help you there. And for this one, you could do this triangle. This one should be easy, right? Because if you have the 120 here, you could ask yourself, well, what does this angle have to be here? So straight line is 180. So 180, that minus 120 is 60, which means this is 30. So you do have your special 30, 60, 90 here. So this triangle should be okay. But the other one, notice we don't have a triangle here. So what I can do, since it tells me JM bisects AC, so JM is here. So that means it's cutting AC in half. So that means if I look at AC, this bottom side here, it's being cut in half. So this piece is equal to this piece. Okay, so what I can do here is if I drop the line here to point M, if I make a right angle here, notice, well, I'll have side angle side, right? So I'll have the reflexive property, the right angle side, reflexive property, right angle side. So I know that these two triangles are congruent, which means I'm splitting this 120 in half. So this will be 60 and this will be 60. Okay, so if you look at this blue triangle over here, that means 30, so this would be 30. And then if this is 60 here in this smaller triangle, this is obviously a right angle, right? Because straight line here. So that's 60, this would have to be 30, right? So we do have two special 30, 60, 90s here. So you could figure out that one as well. So you should be able to spell the joke once you finish off those letters. We already have a decent amount of letters at the bottom here. So to finish off here, so you're just gonna finish this page here, and then there's a short delta math assignment, just like the IXL, just more examples, just so we can really get that practice. Okay, so let me pull my rules here. So let's go through a few of these. So here we have the tick marks here. So that means this is 45, 45, right? So we have a special 45, 45, 91. Okay, so remember my rule for going from the hypotenuse to one of the legs is radical 2, right? So to go from leg, so multiply radical 2 over 1, hypotenuse back to the leg, it's divide by radical 2, right? So I can divide by radical 2 here. So what you'll notice, if I have that radical 3 and I divide by radical 2, let's plot this out here. So I have the radical 3. To go backwards, we divide by radical 2. Okay, so they're both inside the radical, but I can't do anything with 3 over 2. Maybe it was a 4 over 2 or something, but I can't. So the way we do this is we rationalize this. Okay, so multiply top and bottom by the radical 2. Okay, so the top is going to become a radical 6. And the bottom is going to become square root of 4, which is just 2, right? So multiplying gets rid of that. And I can't do 6 is inside and 2 is on the outside, so I can't combine those on the outside and inside. So that would be my final answer. So it lets me do the radical here, so it's be radical 6. When I'm doing, let me get out of the radical when I'm dividing by, I thought there's just a slash button, it makes a division, so radical 2, sorry, just 2. So radical 6 over 2 sounds good, and it gives you the rule there as well. Let's look at a couple more here just so we get the practice. Okay, that's me. Let's find some different ones here. Okay, so these are all, this is also isosceles. So these are just dividing by radical 2. So that's the same type of problem. Let's take a look. Okay, here's a 30, 60, 90. Okay, so always start with the short leg. So where's my 30 is here? Okay, so this would be my short leg here. So this is my short leg. Okay, so for our short leg to hypotenuse is double. So we know that it's not asking for this, but this would be 16. And then short leg to long leg, because this is across from the 90, right? So short leg to long leg. Go back to my rules here. Okay, so short leg to long leg is the times the radical 3, right? So I just had to take the 8 and put a radical 3 at the end. So 8 radical 3. Okay. Gives us some slightly different ones here. Let's take a look at this one. Okay, so it's equilateral. So this is similar to the way we derived the other one. So equilateral means all these are the same. Okay, and then remember, this is being cut in half, so we can cut this in half here because we have side, side, side. So that means if all the angles are 60 in equilateral, right? So this is 60, that's 60. This one, just like the one we saw on the sheet, cut in half. So this is 30 and 30. Because remember, with the equilateral, if I draw the altitude, we know we have just by HL, right? One of the legs of the right and then one of the hypotenuse, just these are two congruent triangles, right? So everything flips over. So 60, 60, 30, 30, everything's the same. Okay, so notice here, 6 is actually the long leg, right? So this one's the tougher, probably the toughest of all the examples. If you start with the long leg. So we always go from to the short leg first. So the 30 is here. So this would be my short down here. And that's what it's asking for the leg. Okay, so to go from long leg to short leg, that's dividing by radical 3. Okay, so to go backwards, we're going to divide by radical 3. So if this is 6 here, we have to divide that by radical 3. Okay, so I take my 6 and I divide it by radical 3. Okay, can't simplify that. 3 is inside, 6 is outside. So we multiply top and bottom to rationalize. So at the top, we have 6 radical 3. At the bottom, we just have 3. Okay, but now these are both on the outside. So now we could do 6 divided by 3, which is 2. And the 3 is still stuck inside, so 2 radical 3. Okay, so that means this here is 2 radical 3. And I know to go from short leg to hypotenuse, it's double, right? So that means this would be 4 radical 3. I just double the value there. So once you have that short leg, you go easily to the hypotenuse just by doubling it. But always a short leg first. Even if it asks for this, you have to go to the short leg first and then just double it. So that short leg is the key part here. Okay, so if I type in the 2, let me get rid of my markings here. So if I type in the 2 radical 3, I said my answer was 2, click on the radical 3. It'll verify that that is indeed correct. And it gives you the work here as well of rationalizing it. So doing this should be helping you practice. And if you need more, you can always do more than necessary, and you have the IXL as well. But just make sure you're okay with these special triangles. So finish off the sheet, do these questions here on Delta Math, and that's pretty much it. Then you have no homework for the weekend, obviously, if you just do that today. All right, I'll see everyone after the extended weekend. Have a good one.